Swam. Okay, hello everyone. So we will be starting with the probability as I have discussed with analog communication. So today we will be doing probability theory and random variables. So as the subject matter is already known to most. out. So we will take the first question. We will take the first question. In probability theory, the expectation of a random variable is a measure of the most likely outcome, or so in probability theory is the expectation of a random variable is a measure of the most likely outcome, the average or mean outcome of the random variable, the square root of the variance, or is it the always equal to zero. So expectation, as we know from basic probability, is the mean of the random variable. It is not most likely. Most likely means where the probability is maximum. So that is called the mode. So most likely, the first option, most likely value means basically you find the x at which the probability distribution fx is maximum. So that is the mode. This is called the mode. So the first option does not refer to expectation but to mode. Next is average. So we know that average is the correct answer. The expectation is the measure of the average. Next, so here we have seen that expectation is the measure of the average. Next problem: the probability of a continuous random variable takes in what is the probability that a continuous random variable takes any specific value. So here you say that in question number 2, fx is a continuous probability distribution. Okay. So fx is a continuous probability distribution. So since it is continuous, that means at a particular point the probability is, say, at a particular point x. How do you find the probability? Now probability for a continuous random variable is defined as the integration between, like, if you want to find the probability that a random variable lies between x1 and x2, what you do is you integrate between x1 and x2 the probability density. That is how you get. Okay. Now here x1, if x1 is x, then the probability that it takes a specific value is it will lie between x and x plus epsilon, where epsilon tends to 0. Now this means it is lying between x and x plus epsilon, fx dx. Now since epsilon tends to 0, the upper limit tends to the lower limit, x plus epsilon tends to x. So you can say you are integrating between the same 2 points. Now integrating between the same 2 points will give you 0 always. So the answer is always 0. The answer is option A. Next is the function fx, which is given as lambda e to the power minus lambda x is a valid PDF where, okay, so it x varies between minus infinity to infinity. Now it is saying that fx equal to where lambda is a scalar. So fx equal to lambda e to the power minus lambda x. Yeah. Now, for fx to be a valid PDF, the probability of a variable lying between minus infinity, probability of the random variable lying between the upper limit and the lower limit should be equal to 1. For fx to be a valid PDF, this integration should be equal to 1. What is this integration? This integration is basically the probability that the variable lies within its stated domain. Now, the variable by definition will always lie within its domain. The RV lying, the random variable lying within its stated domain, that is the domain that is has been set, is by definition 1 because it will always lie within the domain that has been stated in the problem. So the RV lying within its stated domain is a certain event, is a certain event with probability 1. So if x has a domain x1, x has a domain that it lies between x1 and x2, then the if this is the domain, then within its domain, within its domain, the random variable will always lie. So the probability will always be 1. So this has to be 1. Now we have to verify whether lambda e to the power minus lambda x integrates to 1 over the real line or not. So lambda e to the power minus lambda x dx. You take lambda outside, you integrate e to the power minus lambda x. So you get e to the power minus lambda x by minus lambda within minus infinity to infinity. Now, if you put infinity, what you get is lambda e to the power minus infinity. And if you get minus infinity, you get e to the power infinity. Okay, and let this lambda will cancel. So it is just minus 1 into this. So it is ultimately infinity minus 0 because e to the power infinity tends to infinity and e to the power minus infinity tends to 0. So this is ultimately tending to infinity. So it is not equal to 1. Thus, fx is not a valid PDF. Thus, fx equal to lambda e to the power minus lambda x, where x varies from minus infinity to infinity, is not a valid PDF. So thus fx is not a valid PDF. Now, if you change the domain to infinity to 0, instead of the entire real number, you only take the non-positive numbers. So within infinity to 0, it can be shown that fx is a valid PDF. So it can be shown it can be shown that shown fx equal to lambda e to the power minus lambda x 0 to x infinity is a valid PDF. So the same expression, if you just change the domain from minus infinity to 0 to infinity, the invalid PDF becomes a valid PDF. So not only does the function being a PDF depend on the function itself, but also on the domain of the function. Next question. Next question is that uh, next question is the function uh, consider the function e to the power fx equal to e to the power 3x by 4, where x varies from 0 to b. Now find the function. For the function to be a valid probability density, the constant should be. So here the fx is given. Now you have to find b, the domain. So this is the domain. Now, because this is the domain, you have to find that exact domain. So the domain is 0 to b. Now you have to find the value of b. So for it to be a valid probability density, the first thing that has to happen is that fx should integrate over the domain to 1. So fx dx should be equal to 1 over the domain. Now what is the domain? The domain is 0 to b. And what is the function? The probability density function is e to the power 3x by 4. So if you integrate, e to the power 3x by 3 is equal to 4. Now this varies between b and 0. So it is e to the power 3b minus 1 is equal by 3 is equal to 4. So e to the power 3b becomes 13. So b becomes ln 13 by 3. So 1/3 of ln 13. That is the answer. 1/3 of ln 13. So let's see the options. The options are ln2, ln16, 1/4 of ln 12, and none of the above. But our answer is ln 13 by 3. So the correct answer is none of the above. Okay. For the next question, there are two random variables, and there is a joint probability density. So there is fxy, x comma y is equal to this, where the probability of the event, where ux and uy are the step functions. So they are step function. So step function means this is 1 by 12 e to the power minus x by 4 minus y by 3 when x and y are greater than 0. But even if one of them is less than 0, it is completely 0. Okay, so the probability, now we have to find this is our PDF. Now we have to find the probability of x lying between 0 and infinity and y being less than minus 1. Now, if you look carefully here in this particular density function, x is greater than 0. Here x is greater than 0 and y is greater than 0. That means y less than minus 1. This is AND. So the probability of 0, x lying between 0 and infinity, and y being less than minus 1. So if only one of these probabilities is 0, then this whole intersection is 0. Now, since x is greater than 0 and y is greater than 0, so the probability of y being less than minus 1 is 0. Since it is positive, y can never be less than -1. So this condition is not holding. So if p that is not holding, so their intersection will also be 0 because these two events have to hold together. So x has to be positive and y has to be negative for this event to hold. But this is not holding. So this entire event is not holding. So implies p 0 x infinity is 0. So the correct answer is 0. None of this. Because y is greater than 0, so y cannot be less than -1. So the probability is of y less than -1 is 0. And since this is an intersection event and event, so the entire event's probability is 0. Next question. A random variable x is uniformly distributed on the interval -5 to 15. Okay, now uniform distribution means between in the domain of the random variable, the probability of occurrence of any particular subset of the domain is equal to, or rather it's inversely proportional to the length of its domain subset. So here what I mean to say is that if you take, basically the probability density will be constant throughout the domain. So you take one point A, another point B. Now if it is uniform, so this is constant at some level h. This is your uniform distribution. So fx will be 1 by fx will be equal to h for all x within a to b. This is uniform distribution. But now what is the value of h? That is obtained from the condition of PDF that within that domain a to b, the integration will be equal to 1. So h integration dx is equal to 1 implies hb minus a is equal to 1 implies h equal to b1 by b minus a. So this is equal to 1 by b minus a. So that is the PDF. Now, if you want to do the CDF, how do you get the CDF from the PDF? You integrate. So CDF is, say you have this uniform distribution. Now you want to find the probability that your point lies within this region. So the sum total probability of all the points in this region, shaded region. Let's say this is x. This is 1 by b minus a, as discussed earlier. So CDF is nothing but the probability that the random variable is between a and x. So it is integration a to x 1 by b minus a, the density function into dx. So it is ultimately x minus a by b minus a. This is the CDF or capital Fx. So at any point x, the probability that the point for any point x, the probability that a second point will lie to the left of that x is x minus a by b minus a. Now, with that knowledge in hand, we will do. And what is expectation? Expectation is the average. So once you have the probability density, what you do is you weight each point by its probability distribution. So x into fx. So each point x is weighted by its probability distribution fx over the entire domain a to b. This is called expectation. Now, if we want to calculate for uniform distribution, expectation is, so x dx integration is x square by 2. So it's b square minus a square by 2b minus a. Now, b square minus a square is b plus a into b minus a. 2b minus a. So, ex is equal to half of a plus b. Done. Now, now, we come to the question that a random variable x is uniformly distributed in the interval minus 5 to 15. Another random variable y is e to the power minus x5. So what is the value of ey? So here y equal to e to the power minus x by 5. Now x is uniformly distributed. It is said between minus 5 and 15. So it is written as x is distributed uniformly between minus 5 and 15. Now the expectation y is integration. So if x is between minus 5 to 15, then y will be between e to the power minus 5 to e to the power minus 5 by 5 to e to the power minus 15 by 5. So it will be between e to the power minus 1 to e to the power minus 3. So the lower limit is e to the power minus 3 and the upper limit is e to the power minus 1. And you do y dy. Now, transformation of distributions says that if you have a distribution of a particular variable, then a function of that variable will be distributed as, say, if y is equal to gx, say if y is equal to gx, then f of y, that is the probability, is equal to g dash x. So let's not do transformation of distribution here. So we will not be using that. Instead, directly we will calculate expectation of e to the power minus x by 5. So it is between minus 5 and 15, e to the power minus x by 5 fx dx. So what is fx? It is uniformly distributed. So fx will be 1 by 15 minus minus 5. So it is 1 by 20. So if fx is 1 by 20, then expectation e to the power minus x by 5 is 15 to minus 5, 1 by 20 e to the power minus x by 5. So that is 1 by 20 e to the power minus 3 minus e to the power minus 1, sorry, e to the power 1 by minus 1 by 5. So it is ultimately 1/4 of e minus. So the value of this is so this comes out to be 0.667. It is 0.667. Next question. So the CDF of two random variables is pi by 2 plus tan inverse x by 2, pi by 2 plus tan inverse y by 3. For this, the valid CDF value should be, so the CDF of two random variables together is given to be this. So this is a joint CDF. So now we are entering into the territory of joint CDF. Yes. So for this probability density function, now let's go to the solution of this. So the the cumulative distribution function is valid. Like probability density function is valid if the summation or integration comes to be 1 over the entire domain. So we know that this is has to come to 1. Now fx is this a to x, where x lies between a and b. A to b is the domain. So this is cumulative distribution function. Now, so what is fb? This fb, this fb has to be integration a to b fx dx. So this has to be 1. So fb equal to 1, and at the same time fx is greater than 0. All of them has to be always has to be positive, and also fx is should be always Since in cumulative distribution you are adding probabilities cumulatively over time over the domain, so fx should be always an increasing function. Fx can never be a decreasing function because your probabilities are negative, not negative. So when you are adding them, cumulative distribution can never go down. It always has to go up or stay static, but it can never be decreasing. So it has to be increasing, or rather, to be more technically precise, it has to be non-decreasing. It cannot decrease. Okay, next. Now, this function here is and the range is not given. So the first test, it has three tests. So first is that the last value of the domain, the highest value at that point, CDF should be 1. The second is that CDF should be greater than 0. And the third should be that fx is a non-decreasing function. So oh, now nothing is given about the domain. So if nothing is given about the domain, we can always assume that x and y are real. That is, x and y exist between minus infinity to infinity. So in this problem, there is a bit of so the domain, there is a certain ambiguity over the domain. There is a certain ambiguity over the domain. So we will assume that they exist between infinity. So if x comma y at infinity and infinity. So at infinity and infinity it is a by 2 into tan inverse infinity is pi by 2. So pi by 2 plus pi by 2, and here also it's pi by 2 plus pi by 2. So it is a by 2 into pi. So pi square a by 2, which is not equal to, so pi square a by 2. Now for it to be a valid CDF, this should be equal to 1. So A should be equal to, for valid CDF, so A is equal to 2 by pi square. So that is the value. A is equal to 2 by pi square. Next, in a system where packets are transmitted with success probability of 0.9, what is the expected number of trials needed to successfully transmit a packet? Okay, so here with success probability, as you can guess, it is related to success. Since it is talking about success probability, it is related to the Bernoulli distribution or binomial distribution. So it is coming, the expected number of trials is coming from binomial distribution. So So the next part is binomial distribution. So binomial distribution is given as n fx equal to ncx, n choose x, p to the power x, q to the power 1 minus n minus x, where p plus q equal to 1. So, and x varies from either 1 to n. X varies from 1 to n. So either you choose 1 success or n success. So here the expectation of x is given to be here ex will be summation x ncx p to the power x q to the power n minus x. Now this here x will vary from 1 to n. Now this summation boils down to 1 by p. So this calculation, binomial calculation, we are not doing, but it boils down to 1 by p. So the expected number of trials to successfully transmit a packet is just the inverse of the success probability. So it is 1 by zero point 0.9 or 1.11. So the correct answer is 1.1. The envelope of the output signal of a radar system that is receiving only noise is a random voltage x whose PDF is given as x e to the power minus. So So the envelope of the output signal of a radar system that is receiving only noise is a random voltage, which is given as x e to the power minus x square by 2. The system gets a false detection if x exceeds the threshold level of V. So to make the probability of false detection 10 to the power minus 4, what should be the minimum value of V? So here, here there is a radar system and the radar system is receiving nothing. It's just receiving plain noise. But is receiving plain noise. So here the output voltage is given as x e to the power minus x square by 2. So if this x crosses a certain threshold x greater than v, even though we are not sending any signal, the radar will detect a signal falsely. So this is for falsely. That is, no signal has been sent. So even though no signal has been sent by the detector, by the transmitter, the radar will detect the presence of a signal. So that cannot be. So that is why it's called a false. It's called a false positive. So in the absence of signal, you are detecting the presence of a signal. So you are doing false detection, but in the direction positive. So you are finding something when there are none. So that is false positive. And the opposite of this is called a false negative, where even if you have transmitted a signal, because the threshold voltage, because the signal is lower than a threshold voltage, you are detecting nothing. So this is a false positive. Now here the false positive is happening when x is greater than v. So the probability that x is greater than v, we have to find. So this is 1 minus the probability it is x is less than v. Now x less than v means it is the CDF up to v. Okay. So this is given to be 10 to the power minus 4. So now we have to find the cumulative distribution of this particular function. So fx is x e to the power minus x square by 2. The cumulative distribution function or CDF will be given by the integration between the initial point of the domain. So the initial point is 0. So since we are dealing with the magnitude of the voltage only, is 0. And the final point is x. And to avoid confusion, let's put this variable as p. So p e to the power minus p square by 2 dp. So just to avoid confusion between the limit and the probability and the PDF variable. So this is by parts you do p e to the power minus p square by 2. So you integrate. So p integration e to the power minus p square by 2 dp minus integration 1 dp by dp, so 1 into integration e to the power minus p square by 2 dp. So this is now if you solve this, this is not solvable by hand. So you have to take the help of some mathematical tool. So we will go to a mathematical tool. Integrate e to the power minus p square by 2 over 0 to x. So if you do that, the answer will come to be root pi by 2 error function x by root 2. So error function is a particular function that you get by integrating e to the power minus p square. So here you get x, p is x. So x into root pi by 2 error function root pi by 2 x by root 2 erf, sorry, error function. And this error function is got by integrating this. And finally, you have to again integrate. Root pi by 2 will be outside, error function x by root 2, p by root 2 dk. So this is basically a double integration. So next, this is done. So next we will integrate this whole thing. Integrate over now we will integrate error function again, and we will get x error function x by root 2. So it is x error function x by root 2. So here you have x root pi by 2 error function x by root 2, and here you have root pi by 2 into x error function x by root 2 plus root 2 by pi e to the power minus pi x square by 2 minus 1. So here you have this, finally this as the result. Now if you zoom it out and do it, so x root pi by 2 error function x by 2 minus x root pi by 2 error function x by root 2. So you see this error function gets cancelled, plus minus 1 plus, no, sorry, plus 1 minus e to the power minus x square by 2. So this thing gets cancelled. So finally you have 1 minus e to the power minus x square by 2 as fx. So our probability of false detection was PFD was given to be 1 minus FV. So it is 1 minus 1 minus e to the power minus v square by 2. So it is e to the power v square by 2 minus v square by 2. And this is given to be 10 to the power minus 4. So if you take ln on both sides, it is minus v square by 2 is equal to minus 4 ln 10. So v is root 8 ln 10. So you just do calculation, 8 into ln 10, square root of that, and it gives 4.3. So 4.3 volt. If the noise is detected to be more than 4.3 volt, it will lead to a false detection. Okay, so here it is not written in that way. It is written as root 2, you take the 4 inside, ln 10,000. It is written like that, not in float. So this is the answer, but it is written as root 2 ln 1000. So we will take back root 2 ln 1000, and the correct answer is root 2 ln 10,000. So the probability of false detection is root 2 ln 10,000. Now, the next question. A joint sample space for two random variables x and y has four elements: 1, 1, 2, 2, 3, 3, and 4, 4. The probability of these elements are zero point 0.1. A joint sample space has four elements: 1, 1, 2, 2, 3, 3, 4, 4. So x equal to y are the only sample space elements. Now the probability of these elements, so 1, 1 is 0 0.1, 0.35, 0.05, and 0.5. So together they are adding up to be 1. So 1, 1 has a probability of 0 0.1, 2, 2 has a probability of 0.35, 3, 3 has a probability of 0.05, and 4, 4 has a probability of 0.5. So find the probability that x is less than 2 and y is less than equal to 6. So this is the probability you have to find. And the sample space is equal to 1, 1, 2, 2, 3, 3, and 4, 4. So here, if the sample space is 1, 1, 2, 2, 3, 3, 4, 4, then probability x, what is that probability? X is less than 2 and y is less than equal to 6. Now, how many of these events? So since there are only 4 possible events that can happen. So how many of those 4 events satisfy this condition we have to evaluate? So for 1, 1, is this condition true? Let's say this is this condition true or false? In 1, 1, it is true because 1 is less than 2 and 1 is less than equal to 6. For 2, 2, it is false because 2, 2 is 2 is not less than 2. So 2, 2 is false. And 3 is again not less than 2. So 3, 3 is false. 3, 3 is false. And so is 4. So only this is equivalent to P1, 1, the probability of 1, 1. Why? Because 1, 1 is the only event that guarantees this condition. So the probability of 1, 1 is given to be 0.1. So the probability is nothing but 0.1. So the probability is 0.1. So answer B. Correct answer is B. So with that, we are concluding this assignment, and for the remaining 15-20 minutes, we can take some extra questions. We will start some extra questions in those 15-20 minutes. Okay, so now as we discussed, we will be solving miscellaneous questions in probability and statistics that might be important in communication theory. So, so we will be solving some miscellaneous questions now. The first question is, uh, uh, okay, the first question is, if a random communication signal has a PDF given by Px equal to 2a e to the power minus b mod x, then the relation between b and a is. So here PDF is given as, so a PDF is given as 2a 2a e to the power minus b mod x. So 2a, fx probability density function PDF is given to be 2a e to the power minus b mod x. Now, for this to be a PDF, as discussed, it has to exist, it has to sum up to 1 over the entire domain. Now, what is the domain? The domain is minus infinity to plus infinity. That is the entire real number line. So, in the entire real number line, this is over the entire real number line, minus infinity to infinity, 2a e to the power minus b mod x dx. Now, you break down the mod to minus infinity to infinity, you break down as minus infinity to 0. This is a negative x domain. So x will become minus x, mod x will become minus x. So this will become 2a e to the power bx. And another part is 0 to infinity. This is the positive domain. So it here mod x becomes just x. So it is to the power minus bx. dx dx is equal to 1. So 2a by b e to the power bx between 0 and minus infinity, and 2a by minus b e to the power minus bx between infinity and 0. So this infinity e to the power minus infinity will go to 0, and here e to the power minus bx at infinity will be 0. So only the 0 will be give x equal to 0 limit will give a valid value, that is 1. So it is 1 minus 0 minus 2a by b, 1, 0 minus 1 is equal to 1, implies 4a by b is equal to 1, implies b is equal to 4a. So this is the relation for this to be a valid PDF. B is equal to 4A. So the correct answer is B is equal to 4A, or option 2. The correct answer is option 2. Next, a random variable is distributed normally. So now we have come to another distribution which is known as the normal distribution. Now this distribution is very important in communication because noise signal and channel both are modeled using either Gaussian distribution or some derivative of Gaussian distribution or normal distribution. So normal distribution means n01 means, or rather generally speaking, n mu sigma. This means that the probability density function is 1 by root 2 pi sigma square e to the power minus x minus mu whole square by 2 sigma square. So this is the normal distribution. Now it undergoes a transformation y is equal to hx, which is given here. The transformation function is given. The form of the probability density function of y is so here what will be the format of y? So it will have two impulses and a continuous function. That is clear. So it will have two impulses and a continuous function. Now, what will be the impulse shifts and what will be the general format? That is what is what is to be found. So here the function is given as y is equal to 0, 1, x plus 1 and x minus 1 in 4 different places. Sorry, not 0. Y is equal to 0, 1, minus 1, x plus 1 and x minus 1. These are the 5 places. So these are the 5 pieces of this function. So starting here it is y equal to minus 1. Then we have y equal to x plus 1. Next we have 0, y equal to 0. Then we have y equal to x minus 1. And then we have y equal to 1. So these are the 5 pieces of this function. Now, given that this filter is applied on the normal distribution. So the normal distribution will take the values minus 1, 0 or 1. So the probability density function at this point, since this becomes minus 1, so hx here, h of x is minus 1 and this is 1 and these are constant. So 0, 1 and minus 1 are constant. So after transformation, these three pieces become constant. So at these three places, we will have impulse. So here we will have an impulse at 2, will have an impulse at minus 2. And sorry, we will have an impulse at y equal to 1 because it is taking the value 1. We will have an impulse at minus 1 because it is taking the value minus 1. And we will have another impulse at 0. So plus 1, y is 0 and minus 1. And along with that, these two straight lines will give a continuous function, so plus 0. So the correct answer is option 2. The cumulative distribution means the distribution of x up to that variable value. So CDF basically gives, like if you have a distribution like this, up to x, like this is the fx, then CDF is basically this area up to x. So all the probabilities that are happening up to x. So in another way, we can say that CDF fxx is the probability that x is the random variable is less than this particular value small x. So the CDF at a point small x is the probability that the random variable involved is less than the value of small x. So that is done. So fx is equal to px less than equal to x. Option 1. Now, a continuous random variable x has a probability density function e to the power minus x. Then px greater than 1 is. So here it is again an easy question. So here fx is given to be e to the power minus x, and you have to find the probability that x is greater than 1. So the CDF that we have found, that is usually in the format of less than. So usually we write 1 minus px less than equal to 1, because there are two mutually exclusive events. Either x can be less than equal to 1 or it can be greater than 1. It cannot be both together. So the sum of these two should add up to 1. So we can write px greater than 1 is equal to 1 minus px less than equal to 1. Now, what is the probability px less than equal to 1? That is the CDF. That is the CDF. So 1 minus f1. So the CDF is starting from the start of the domain. So the start of the domain is at 0. So from 0 to 1 e to the power minus x dx. So e to the power minus x dx. You integrate 1 minus e to the power minus x by minus 1, 1 to 0. So this becomes 1 minus a inverse minus 1 by minus 1. So 1 plus e inverse minus 1. So it is e inverse. So the probability is e inverse. Px greater than 1 is e inverse. So that is the answer, e inverse. So it is 1 by e, or e inverse. Next, if next is 1 by p. Okay, now when instead of continuous variable we use discrete variable, then it is called a probability mass function instead of a probability density function. So when there is multiple discrete points at which the probability is defined, it is called a probability mass function. And this mass function is given as -1 is 0.3, 0 is zero point 0.4, and 1 is 0.3. So the PMF is given as the PMF is given as there is a 0, at 0 it is 0.4, at -1 it is 0.3, and at 1 also it is 0.3. So this is -1, 1, and this is 0. Now we have to find the expectation and variance. So expectation is simply, this is the PMF f fz. So expectation is just the summation of the product of the random variable and its PDF or PMF. So random variable multiplied by the PDF or PMF summation. So it is basically the weighted average of the random variable weighted by its own probability density function or probability mass function. So here it is -1 into 0.3 plus 0 into 0.4 plus 1 into 0.3. So the average is 0. Now we have to find the variance. Now variance is, as you recall from your class 12 knowledge, variance of z is expectation of z square minus expectation of z whole square. Now we have to find expectation of z square. So expectation of z square is nothing but summation z square fz by similar logic. And expectation z we know is 0, so it is just 0. So we have to just find summation z square fz. So -1 square 0.3 plus 0 square 0.4, so that is 0 only, plus 1 square 0.3. So these two are 1, so 0.3 plus 0.3, so it is 0.6. So the variance is 0.6 and the expectation is 0. Now, here the random variable has a probability mass function PMF as k if x equal to 0, 2k if x equal to 1, and 3k if x equal to 2, and 0 elsewhere. So now we have another PMF, and the PMF is given as x. PMF is given as sorry, fx equal to k if x equal to 0. So let's write in tabular form x and fx. So it is k if x equal to 0, 2k is if x equal to 1, 3k if x equal to 2, and rest is 0 elsewhere. So now fx is PMF. Any PDF or PMF must sum up to 1. PDF slash PMF must sum, must integrate or sum. Integrate in case of PDF and sum in case of PMF. Integrate up to 1. So integrate up to 1 or sum up to 1. So here it will sum up to 1. So summation fx over all x should equal 1. So it is k plus 2k plus 3k. These are the three values. And it should equal 1. So implies 6k equal 1 or k equal to 1 by 6. Now the question is, to determine the value of k. So the value of k is 1. Now find px less than 2. Px less than 2 is just px equal to 0 and px equal to 1. So it is k, px equal to 0, the only two which satisfy are px equal to 0 or x equal to 1. So since it is OR, we can add the probabilities. So x equal to 0 plus px equal to 1, because these are the only two events that are satisfying. So this is x equal to 0 is k and this is 2k. So it is 3k. So it is 3 by 6 or half. So px less than 2 is half. Next, what we will do is we'll take px less than equal to. Now px less than equal to 2 is either px equal to 0 or px equal to 1 or px equal to 2. So it will be the sum of three probabilities, k plus 2k plus 3k. And we know that is equal to 1. So this is 1. So what is px greater than 2? Px greater than 2 means it is the complement of px less than equal to 2. It is not the complement of px less than 2. It is the complement of px less than equal to 2. So it is 1 minus 1 equal to 0. So the x can never be greater than 2, as is demonstrated here also. X is, after x greater than 2, the probability is 0. So with that, so it is x less than 2, x greater than equal to 2 is half, and x greater than 2 is 0. So with that, we will conclude our class today. Thank you for coming.